Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today we have a soil mechanics problem and we will solve this problem by finding the different unknown parameters. So let's start this soil mechanics numerical. It states that a wet soil sample has a mass of 2.290 kg and a volume of 0.00115 cubic meter. So a wet soil sample has a mass of 2. So I can write it here. The given data we state that the wet soil sample. So the mass of the soil sample is 2.290 kilogram, and it has a volume of 0.00115 cubic meter. So its volume of the soil sample is 0.00115 cubic meter. After being completely dried in an oven, the mass of sample is 2.035 kg. It means that it is placed in the oven and then the dry mass of this soil sample comes out to be 2.035, because after being completely dried in oven, so the mass of the sample will be a dried mass now. So the dry mass of this sample is 2.035 kilogram, right? Before it was wet and now it is dried, so the weight is now less because because the water content has been evaporated. The value of the GS for the same soil is 2.68. The value of the GS means the specific gravity for the soil sample is 2.68. It is also given to us, and we want to determine the bulk density. It is density, right? Determine the bulk density, unit weight, water content, void ratio, porosity, degree of saturation, and the air content. So different unknown parameters which are used in the soil mechanics are mostly unknown to us, and we will find one by one in this problem. So according to the given data, we will solve our problem and we'll find the unknown ones. So the first one is determine the bulk density, right? So the first one is density, right? Bulk density is unknown to us. So we can write it here. Bulk density is equal to the unknown, and bulk density is equal to the mass per unit volume, right? Mass per volume. So we can write it the wet mass divided by the total volume. We will get the density, bulk density of the soil sample. So mass is known to us, which is 2. Here I can write it. The mass is known to us, which is 2.290 kilogram divided by the volume, which is also given to us 0.00115. So by dividing these one another, I get value of 1990 kilogram per cubic meter, because the mass was also in kilogram and the volume was in meter. So the kilogram per cubic meter is the unit of the bulk density. So this is the bulk density of the soil sample. Now the second one is unknown to us, is the unit weight. So to find the unit weight, we know we can write it here. The unit weight is unknown to us, right? Unit weight, and the unit weight is equal to the gamma, represented by gamma, can be found out by dividing the weight of the soil sample by the volume. The unit weight is the weight per unit volume, while the bulk density is mass per unit volume. So in case of the weight, we know that the weight is equal to the mass of the soil sample into G divided by the volume. The weight is known to us, which is equal to the W is equal to mg, right? This is the formula in the physics. We can see here that the weight is equal to the mass into gravitational acceleration. So I put it here, the W weight is equal to the mass of the soil sample into gravity and divided by the volume. So we will get the unit weight of the soil sample. So here is, we know that the mass of the soil sample divided by the volume is given as this value 1190, right? So this value is known to us, and we will just multiply by the G, right? The unit weight will become out to be a mass per unit volume is the rho here. You can see here rho into G. So I will again write it here. The rho is we find out that it comes out to be 1990 into G is 9.8 meter per second square. So the gamma value unit weight of this soil sample comes out to be 19500 Newton per cubic meter. So this was the method how to find the unit weight. The other one is the water content, how to find the water content of this soil sample. It is also simple. We can find out your water content here by the water content. Water content is equal to the unknown. So water content can be found out represented by W, small w, and water content is equal to the wet mass of the soil minus the dry mass of the soil divided by the dry mass of the soil. So it means the water here, if we subtract the MW minus M dry, it means the water present in the soil sample, because MW is the wet mass and dry is the dry mass. So if we subtract the dry from the wet, we will get the how much the water is present divided by the mass of the dry. So we will get the water content present in the soil sample. So it comes out to be MW is also known to us, which is 2.290 minus M dry is 2.035 and divided by the MD, which is 2.035. So we get the water content of 0.125, right? Now by multiplying it with the 100, W is equal to 0.125. Multiplying it with the 100, we will get the percentage of the water content. In terms of the percentages, it is 12.5% water content is present in this soil sample. So now the other one is the wide ratio. The wide ratio, fourth one is the wide ratio. So wide ratio can be found out, is unknown to us here, by using this formula. This formula is used to find the wide ratio when all the parameters are known to us, and to dim minus 1. So here in this case, a wide ratio is equal to the G specific gravity into 1 plus water content into the density of the water divided by the density of the soil sample and minus 1. So all the values are known to us, and we will simply put the values and we will get our unknown parameter, the wide ratio. So wide ratio can be found out. GS is known to us, which is 2.68 here. Now the sorry, it cannot be seen here in the video, so I will write here E is equal to the GS. GS is 2.68 here, right? And the 1 plus W, W is 0.125. You can see here 0.125 is the water content, right? And rho W is the density of the water. Density of the water is known to us. The density of water is 1000 kilogram per cubic meter, right? 1000 kilogram per cubic meter. So I can write it here 1000 divided by the density of the soil sample, which we found here. So the density of the soil sample is 1990, and then minus 1, because minus 1 is here. So I will just put the values in this formula. So I will get my wide ratio here. The wide ratio comes out to be, after calculating, we get the wide ratio, and wide ratio comes out to be here 1.52 minus here minus 1, right? So after calculating this, we get 0.52. So we get the wide ratio of this soil sample comes out to be E is equal to 0.52. It is very simple. We know that this formula is used for the wide ratio, because you will use that formula to find the wide ratio. There are different formulas, but you should use this formula from which you can get the unknown parameters. As we know that all the parameters are unknown to us, so we use this formula to find the wide ratio. So very simple, and we found out that the wide ratio comes out to 0.52. Now the porosity. Porosity is unknown to us. The fifth one is the porosity. So porosity can be found out very simply from the wide ratio. Porosity is unknown to us. Porosity is represented by N, small n, and is equal to the E divided by the 1 plus E. Very simple. So E is 0.52 and divided by the 1 plus 0.52 E. Again, so I will get my porosity value of here in this case 0.34. It comes out to, it means if you multiply it with the 100, we get 34%. So 34% porosity is present in this soil sample. Now the other known unto us is the degree of saturation, right? Degree of saturation is unknown to us. So we can find the degree of saturation here. I will remove this value because we found out. So we will put the values here in the degree of saturation formula. Now to find the degree of saturation, the sixth one is degree of saturation, right? Degree of saturation represented by SR is unknown to us, and SR is equal to the formula used is W into GS divided by the E. So W is known to us water content, which is what I have found it here 0.125. 0.125, and the G is the specific gravity of the soil, which is 2.6, is divided by the wide ratio, which is 0.52 here, right? So divided by 0.52, I will get the degree of saturation, which comes out to be 0.64. So multiplying it with the 100, we get 64%, right? 64% is the degree of saturation of this soil sample. Now the last one is known to us, which is the air content. How much air content is present in this soil sample? So air content can also be found out easily. Air content is unknown to us. A is unknown to us. So A can be found out by this formula, AN into 1 minus degree of saturation. So A will be equal to the N is porosity is 0.34 here, and 1 minus degree of saturation is 0.64, right? So if I subtract this and multiply it with 0.34, we will get the degree, air content, which comes out to be 0.121. So if I multiply this with the 100, I will get the air content in the terms of the percentage, which comes out to be 12.1%. So 12.1% air content is present in this soil sample. Hope you guys understand the different formulas in the method how to solve each unknown parameter. We should use this formula to find the unknown parameter, in which we should know the parameters. For example, for the wide ratio, I use this formula. Why? I didn't use this formula for the wide ratio to find it, because we don't know about porosity. So we use this formula because all the parameters were known to us. So we just put the values in this formula and we got our wide ratio. You should also use this formula, those formula in your problem, in which you should know all the unknown parameters so that you can find your entrusted parameter easily. Hope you guys understand, and don't forget to subscribe my channel for daily civil engineering videos. Thank you for watching my video.